I don't know. Ask Kanye West. He said.
I thought it was Pelosi that said that.
That was Kanye West that said that.
Seems legit.
Yep.
He said it on TV.
Yeah, he said it, and Michael Myers was standing right beside him, and Michael Myers was like, he had this look on his face like, what?
I would never get on TV with him.
I wouldn't either. There's no telling what he'll say. All right, Hooke's Law. I want to show you Hooke's Law, and then after today, we're pretty much in test mode. Now, I'll explain that, and because we got to have an in-class test that y'all can't pass. Don't forget, we got to do that. Hooke's Law. Having to do with dang old springs. Oh, we gotta fix this too. I hope everything works today. We got us already started.
Just switch classrooms.
That would be too easy. I've tried to hit this stupid thing twice, and I don't know what's causing it to do what it's doing, but
Let's do a little more to the left.
yeah, but it shouldn't be that way.
You might need to calibrate it.
Good gosh. This is Bush's fault too. Everything is Bush's fault. Marlboro Reds kill you. Okay, people. Okay, now the pins are going to work today. The pins are going to work today, people. All right. Hooke's Law, of course, has to do with springs. And a lot has to do with at rest. So, or at its natural position. So, whenever you're dealing with a spring, there's 2 or 3 positions. The first is at rest, then there's compression, then there's return. Okay? So, 1, at natural state, or at rest, and then there's compression, or extension, or pulling, and then there is return. Now, later on, you're going to be getting into a lot of vectors with your physics, and you'll be getting into negatives and positives and all that good stuff. But we're trying to focus mostly on the mathematics, okay? So, you physics people, just chill out. Don't try to get us in some kind of physics conundrum. So if I have a spring and I'm putting 5 newtons of force on it. Then the spring is pushing back, what? 5 newtons. Now technically, let's go ahead and get this out of the way because I don't want to have to deal with this later. There's 5 newtons going in the left direction, so that would be what? -5. And 5 newtons going in the right direction would be +5. So we got that out of the way, all right? So I don't need to get into all that crap, all right? Right here, or sorry, this is where we started. This right here is basically the distance that we're talking about, and that's usually where the question is going to be answered, or the question is going to be asked. How far will it move? Okay. It'll give us, usually the Hooke type problems will say if 5 newtons moves at 3 inches, how many will 15 newtons move? Or something like that. That's where we're going to get, that's some of the questions we're going to get. If we had one that moved at 10 newtons, which compresses it even more. Then what is the compression for 10 newtons? Well, Hooke's law is not all calculus. Hooke's law is pretty much algebra. And then we, of course, integrate calculus in there. Hooke's law says F is equal to K times X, where K is some constant. Now, before we go into constants, I want to kind of review something that y'all did back in algebra. All right? So let me go to another page. Y'all remember something called direct variation? Y'all remember that? Okay, I'm fixing to lose it. I'm fixing to get irritated. What?
Might be a little pinhole in the wall. Technology.
Variation. There was direct variation, there's inverse variation, and then there's joint variation. Y'all remember that? Yes or no? Just tell me. You don't, okay? One person, yeah, I remember it. Shut up. Okay? Basically, you got the three. Y is equal to K times X. Y is equal to K over X. And Y is equal to KXZ. Y'all remember seeing those? Okay, that's direct, that's inverse, and that's joint. Now, what's in common with all three of them? K. And K is what you call, how many of you have ever heard of fudge factor? Okay, if you've been in physics or science before, you've heard of a fudge factor. It's the number that makes what? Makes the equation work. Yes, class, that's what it is. Okay? It's the number that makes the equation work. Think of it like this. If you had a recipe that made 24 cookies, okay? And I told you that I wanted to make 48 cookies. You'd say, oh, just double everything. Well, how'd you come up with doubling? Well, 48 divided by what? 24. That's called a constant. You multiply by 2 everything that you put in. What if I wanted to make 72 cookies? then I'd divide 72 by 24, and you get what? 3, and you multiply everything by 3. If I wanted to make 102 cookies, oh my gosh, well, you'd take 102 and divide it by 24, whatever that is in your calculator, and you'd multiply that by the ingredients. So with the cookie example, you have a factor, a number that you multiply by. Now, I'm not going to go into each one of these. I'm just going to go over one kind of a review, just so you understand what a constant is. Let's say that y is 4 and x is 6. And we're doing a direct variation. Well, then you take 4 and 6 and you plug it into the direct variation. So 4 is equal to k times 6. Divide by 6. And k is equal to what?
2/3.
2/3. K is equal to 2/3. Now what do you do with k after you find it?
Plug it in together.
You plug it back into the original equation, and you have y is equal to 2/3. Look how good it writes on this side. Y'all notice that? It's me. I'm doing it. When I go to the right side, I write crappy, and when I come to the left side, I don't write crappy. Times x. And you just found k and you plug it back in. Y'all remember doing that now?
It's kind of like a slope.
Yeah, it's kind of like it. So that's what you're doing. You're finding k, you plug it back in. Hooke's law does the same thing. Hooke's law says that if you're given 10 newtons, and let's say that this distance right here, let's erase it, and let's say that I give you this distance. I think I got a distance here. I just want to make sure I do. Where's my page? Lost my notes. Here it is. I put a distance there. Yeah, 10 meters. Okay? Then I go ahead and I plug it in. My force here is 5 newtons. Is equal to k times what? Okay? And you divide. And k is equal to 1/2. Now, with this spring, let's call this a red spring. Let's say it's red. This is a red spring. And this is a red spring. And this is a red spring. Now, for all these problems with a red spring, k is equal to what? 1/2. Now, if I put a blue spring in, then you got to do what? You got to do it all over. But you got to be given the information right here. You can't be just arbitrarily be given a spring and y'all figure it out. Then y'all would be engineers and y'all don't need this class. Okay? So, let's do an example. I got one to do with feet, and I got one to do with meters and centimeters and all that good stuff.
Is there a unit that turns out to be?
This work, foot pounds, and joules. But once you find, I forgot to do this. Once you find K, then you can plug it back in, and F is equal to 1/2 X. Now, where's the calculus involved? Well, the calculus is basically right here. The calculus says that A to B, work equal to A to B of 1/2 or K X dx. Your Hooke's law is right there. Your constant times your displacement. And the displacement is the difference between where it is at rest and where it's being pulled, or where it's at rest and being what? Compressed. You're either going to have one or the other. Okay? So, a force of 10, now my finger writes. Sorry, I must have turned my finger off. Oh, sorry. A force of 10 pounds is required to hold a spring stretched 4 inches that don't make no sense. I must have wrote something down wrong. Oh, beyond its natural length. To hold a spring 4 inches beyond its natural length. Natural length is resting. How much work is needed? How much work is done or needed to move it from the natural length to 6 inches? To move it 6 inches beyond its natural length. How much work to move 6 inches from natural length? Okay, so you got a force of 10 pounds, basically moves the spring 4 inches beyond its natural length. And they want to know how many pounds or how much work to move 6 inches of its natural length. All right, take a minute and see if you can set up and find K. I just want you to find K right now. Now remember, it's got to be in feet, because everything is done in feet, because what is work done in? Foot pounds. So there's a problem. And what's the problem? It's in inches, so you have to change that to feet. Now that's the only thing you got to be careful with these problems. And with joules, it has to be meters, because of Newton meters. Please stop coughing. You're not supposed to cough in class. Marlboro Reds are going to kill you. What?
He's offering me drugs.
Don't give her any drugs. She's already high, probably.
Yeah, that's what I was saying. I don't want to get her drunk or anything.
She probably did a couple of lines of cocaine before she came in. Her mother probably gave it to her.
You know me so well.
What?
You know me so well.
What?
Right, I was trying to figure out why I'm back here. Must be like a physics and physics 2 test today. We got a test today because this kid right here is in my class.
Mm-hmm. All right, so 10 pounds, that'd be our force. I'm just going to draw a little line here. 10 pounds is equal to K times dang old 4 inches. Well, 4, you got to put that over 12. Dang old variation. 10 is equal to 1/3 K. So K is equal to what? Dang old take that K and put it where? Right there, Hubert. And then set up your parameters based on how much is being moved.
We have to set our parameters in feet also, correct?
Yep.
So,
Remember, when you're doing Hooke's law and you're dealing with, now you didn't worry about that with the tanks because everything was done pretty much in what? Feet and meters. Remember? Okay. The reason it's not done here is because not a lot of springs are pulled in feet and meters. Most springs are pulled in inches and centimeters.
so you go from 6 to 4 or 6 to 0?
6 to 0 because it says it's at resting point, at natural state. Now we're going to do one in a minute where it's from not resting state, and that way you'll know what to do. So, work is equal to 0 to, and I'm going to write 6 inches, don't have a cal, all right? 6 inches of 30 x dx. Now the problem that we have is this guy. That's not in. So W is equal to 0 to what? 1/2, or yeah, that's fine. 0.5 of 30 x dx. All right, finish it. And if you can't do it, just consider yourself a failure. Good. And you should live in a ditch. Yeah, I wish that next Saturday would hurry up and get here. I want everybody to go vote now. I gotta go get some signs and put up some signs. I also gotta run over some signs too. Oh, I'm sorry. You're not supposed to hear that. I ran over one last night.
Did you really?
Yep. Somebody put a Jeb Bush sign out in front of the driveway for this thing. So I ran over it. Why would you put a Jeb Bush sign in front of a thing for... That's stupid.
Well, there's a lot of cruise ones up, so you need to go hit all them too.
Yeah, but those got T-posts on them. I'm going to steal the T-posts
Yeah,
though.
but there's strings too. So all you gotta do is cut the strings.
Yeah, but I got to get those T-posts up. I got to get my lever to pull them up.
That's a great idea.
Dang old $5 a piece. I'm dang old use them on the farm.
Especially snow Monday, so that'd be a good idea to do that.
I'm just kidding. Y'all gonna run over all these things and blame them on me is what y'all gonna do. Huh? Well, you gotta know how to hit a T-post.
I take a picture after each one I hit. Will I count as one point I cut it?
What?
I take a picture after each one I hit. Will I count as one?
Well, it all depends on the big ones.
I'll knock out about 30 or 40 points right now.
No, that's on video. I can't condone that. One of y'all gonna knock it down and get me in trouble. No, I do not condone knocking down Trump signs. Or what's his name? Bernie Sanders signs. All right, so let's set this thing up. It's just tedious. I mean, this is not very difficult. Y'all should be saying to yourself, golly, these are easy. Well, yeah, because you got a fantastic teacher. All right, so W is equal to 0 to 1/2. I'm going to use 1/2 so I don't have to rely on a calculator. 30 x dx. W is equal to 30, 0 to 1/2 of x dx. W is equal to 30, brackets, x squared over 2, evaluated at 0 and 1/2. I'll do 0 for you. That'll be 0. So our final outcome is 3 times 1/2 over 2 raised, or 1/2 to the second power. Okay, is that what we got?
It's supposed to be 30.
Oh, 30, thank you.
Dang, 30.
Dang over. Tell you what. 30 brackets 1/4 divided by 2 over 1. And that's 1/4 times what? 2. Did I do that right? No. 2 over 1. Yeah. 1/4. Yeah. So it'll be 1/8, right? 30 over 8. Is that what y'all got? But you can reduce that down to 15 over what? 4. Which you can reduce that down, dang old 3.75. Whatever. I can't even write on this side. I don't even know what. I write right here and it goes down here. So I think it's 3.75.
But how is it that less work is needed to move it further?
What? I'm sorry, I hadn't.
It was 1/3, and the 30 was not the work, or the 10 was not the work.
Oh, that's right, of course. Okay.
Why are you asking questions like that? Get out. No, hold on a minute. No, it's not work. Yeah, you're right. The force, when it starts off, it starts with force. Work is equal to force times what? Distance.
So why do you use 0 to 1/2 and not 1/3?
Because the question says from at rest. It says, when it says, it says how much work is done from the natural length to move it from the natural length to 6 inches. That's what it says.
Now, if it had said how much
6 inches beyond the natural length.
how
I'm
much
sorry.
more force would it have taken to move it from the position of 4 inches to 6 inches?
Yes, it's going to say that.
1/3 to 1/2?
Yes, that's what we're fixing to do with this one.
Okay.
If you'll give me time, if I can be in charge for a while. Okay? Take my lightning storm away from me. We're going to do one now that's joules, so y'all can spaz on it. Okay? Huh?
9.8.
Yep. No, we don't have to do 9.8 on this one because there ain't no dang old acceleration. But y'all can take it up with y'all's physics teacher. I'm trying to find, I think this is it. Suppose two joules, and I'm going to put joules, I'm going to put out here Newton what? Meters, because that's the cue that everything has to be in meters. Just like a while ago, everything needs to be in foot for foot pounds. Of work is needed. Okay, we're getting toward this end, so it's going to get all funky. To stretch a spring from natural length of 30 to 40 centimeters. Centimeters to 42 centimeters. Okay? And of course it keeps things, so can't read that last section. Let me try it again. Well, there's something major wrong with this thing. I can't even hit the... Wait a minute, I'll do this. I'll put it over here, and then I can hit it.
So whenever you say that, you mean rest?
Natural length.
Okay.
Natural length is at rest, yes.
Yes, we're going back.
All right, so this is kind of like your information. All right. How much work is needed to stretch to stretch or whatever, move the spring from 35 meters or 35 centimeters to 40 centimeters. Now you're going to have to do some thinking here. First of all, find K. Now finding K is not that simple, but if you're already trying to figure out the second part of the problem, then you need to be quiet and worry about the first part, okay? First part is find K. 2 is equal to the integral, because we're dealing with work. What does it say up there? It says work. Does it say force or does it say work? It says work. So you got to do 2 is equal to the antiderivative from blah, blah, blah to blah, blah, blah of kx dx. I really think you can find that. I have faith in y'all. No, I really don't. Now, your in-class test that will be just awful will consist of 5 work problems that will come from your online test. You with me?
Is it open?
No, the in-class test has to be as hard as it can be. It has to, no notes, no anything, and it has to be just about impassable. Okay?
You say that's online?
All right, let me say it again. In the class test that y'all are supposed to take that is just awful, it's going to be 5 work questions from the online test. See, I'm supposed to give y'all an in-class test. It's just awful. It's terrible. Because I have an 87% retention rate, I'm supposed to bring that down a little bit. So I got to give y'all an in-class test. Y'all understand it now?
Yeah, and it's not like you can have people actually pass classes.
Huh?
It's not like you can actually have people pass classes.
Yeah, it's awful.
Yeah, then they would move on and then.
Yeah, especially when you, go up to my department head and tell her how much you've learned in here. That's about 2 of y'all did that. And I went, yes. Because I know she went, oh, not really. When you got an 87% retention rate versus a 6% retention rate. All right. I'll shut up. How much work to stretch the spring 35 to 40 centimeters? Well, let's worry about the second part. Let's don't worry about K. Well, if you're going to do that, you're going to end up getting in trouble. So let's worry about K first. So I'm going to just draw a little line right here. And since this guy right here is not force, we got to work with integration. So work is equal to the antiderivative from some number to some number of k x dx. Now, what do we got? 2 joules is equal to some antiderivative k x dx. Now, a lot of you are saying, I don't understand how we're going to solve this. Well, what are you going to be plugging in? Say again? X. So what are the variables left? K. So you're going to solve for K. So we got to figure out these two guys. Well, we're got this out of the way. Okay. Natural length is what? What is that? 0. Thank you, class. Oh, I'm sorry. 30. Sorry, 30. It's from 30 centimeters to what? 42. Well, this is what? Technically, that's what? 0. But this is 12 centimeters. Well, 12 centimeters don't mean squat because of that. So, King, Henry, died, meters, liters, grams, drinking chocolate milk. And we want to change centimeters to what? 1, 2. So 12 centimeters is point what? 0.12 meters. So 0 to 0.12. Now I'm not going to use 0.12. I'm going to use something else. I'm going to use a fraction because I don't want to have to use a calculator. Finish it out. And if you can't, then just mark it up.
So you're not trying to find the work from 35 to 40?
How far did the spring move? You got to read the question. What does it say 30 is? 30 centimeters. What they're trying to do is trick you. All right, look. What they're trying to do, there's your wall. Your spring is how long? 30 what? Centimeters. That's the spring. It's 30 centimeters. And it's being stretched to what? 42 centimeters. Okay? What is this spot right here? That's rest. Remember me showing you at rest at the beginning of class that you didn't write down? Talking to your brother. Okay? At rest. So at rest is equal to what? 0. You understand it now?
Yeah, but, yeah.
You got to remember, Hooke's law is from A to B. At rest means 0. Okay? Now, when you throw this into it, this, you got to think a little bit differently. Okay? But we're just talking about find K. So, where am I at? Okay, 0.12. You can use a fraction. What? Let's see. I'm trying to think of a fraction for 0.12.
1/8.
Huh?
1/8.
1/8? Okay, good. So let's use 1/8. I'm going to use 1/8 because I don't like having to rely on a calculator. So 1/8, that's going to be 1/8. So let me go to the next page. 2 is equal to 0 to 1/8 of k x dx. 2 is equal to k x squared over 2 evaluated at 0 and 1/8. I'll do 0 for you. 2 is equal to k brackets 1/8 squared divided by 2 over 1. 2 is equal to k brackets 1/64 right? Multiplied by 1/2. Yes, Hubert. No, Hubert. Thank you, class. 2 is equal to K times 1/128. No, my finger wrote 288. See how things work better when I move this over here? Is that operator error? Okay, thanks, y'all. How do you do this? Well, multiply both sides by what? 128. K is equal to, dang old, 256. Somebody help me out. Now, somebody tell me what you got when you did the decimal.
278.
278. Why? Why is there a difference?
Because 0.12 isn't exactly 1/8.
That's it. That's why. But I did it with 1/8, so I wouldn't have to use a calculator. Okay. Now, of course, you don't want to do that, but I did 1/8. I just did that because I didn't want to have to ask y'all, because half of y'all tell me the right answer and half of you tell me the wrong answer because you want me to mess up. Okay, so that's why I don't use a calculator with y'all. Mr. Blair does it all the time. All right, now finish it. You just found K. K is equal, was it 278? Did you round up or was it decimal? Or
It was like 277.77.
okay, we'll use 278. K is equal to 278. Let's go back to the original equation. That's not it. There it is. How much work to stretch the spring from 35 centimeters, which is how much further than this? 5 centimeters. So you got to take that into account. 40 centimeters, 2 centimeters. So you got to take that into account. What is it? What's so funny?
So would you do 10 as your integral as you go 0 to 10?
I don't know.
I don't know either, that's not bad.
Well, what's the difference between 30 and 35? Okay, so change that into meters. 5 centimeters would be what? Way to go. My dang old King Henry died. And what's the difference between 42 and 40?
See, okay.
But you got to remember, no, I'm sorry. What's the difference between 30 and 42? 12. Oh, no, I'm thinking. There's got to be, there's be 0.10. It would be 0.10. Right? 10. How much has it moved?
Well, it moves 5, but don't you have to go from
5, yeah.
You got to add the two together and get 10. There should be 10.
Yeah.
Yeah, that's what I was thinking.
Yeah, wouldn't it be just from?
Okay. Yeah.
Starting at no half.
0.10. Would it be 0.10?
Yeah.
Yeah. 0.10. I'm sorry.
20th to 110.
Yeah. So it'd be 0.10. Where does the 10 come from, people?
40 centimeters.
Say again?
40 centimeters is 10 centimeters fast.
Exactly. Because remember, this guy right here, where does the spring end? The spring ends at where? 40. Where did it begin? 30. All right. So it traveled a distance of what? 10 centimeters. Now, where does the beginning start? The beginning starts not at 0, but at what? 5 centimeters. 30 from 35. So it started at 5 centimeters. Okay, and it ended at 40, which is 10 centimeters from the beginning. Everything focuses around this guy. Now, if you draw a picture, it will help you tremendously. If you're sitting there trying to do it in your head, just forget it. Just write it down and just watch the video again. Draw a picture. I'm not going to draw a picture because I can't do anything on this board today. So, what I got is W is equal to 0.05 and 0.1 of, did we say 278? X dx. And that's going to be W is equal to what's 2,500 over 9?
277.8.
Okay, let's go with 2,500 over 9. I'm just changing it to a fraction because I don't trust y'all. Y'all probably told me that wrong. 2,500 over 9 x dx. So W is equal to 2,500 over 9 integrated, and we can change 0.10. That'd be 1 over 10, right? You could do 1 over 10 here, and what would be 0.05? That would be 5 over 100, right?
1 over 20.
1 over 20. And I'm doing this just so I don't have to do, oh, I forgot my dx up here. Don't forget your dx. Dx. And so that's going to be W is equal to 25 over 9. And then brackets, the 110 squared over 2. 1 over 10 squared over 2 over 1. Love this right side over here. Just forget it. Let me just do it over. W is equal to 2,500 over 9. And what I say, 1 over 10 squared over 2 over 1 minus 1 over 20 squared over 2 over 1. Is that everything in there? So W is equal to 2,500 over 9, 1 over 100 multiplied by 1/2 minus 1 over 400 multiplied by 1/2. That's going to be W is equal to 25 over 9 multiplied by 1 over 200 minus 1 over 800. And that's going to be what? 2 and 4 to be 4 over 800, 3 over 800. So W, I'm not going to write it over there. W is equal to 2,500 over 9 multiplied by, what did I say? 3 over what? 800? I'm looking to see 3. I'm looking, just hold on. I got 25 over 24. What'd y'all get? 25 over 24 would be 1 point something. W equal 25. Let me see how much I can do this. Let's see. 24 be 1. That'd be 10. 1.4 or 1.04? What'd y'all get?
Yeah.
1.04?
Yeah.
It's amazing. I did that without a calculator. Wow. I must be like wicked smart. What do you think about that, Miss Anthony? You do that whole thing without a calculator.
That's great.
I'm sure you did that, didn't you? Mr. Anthony's on the calculator drill team. All right. Guess what? We're done. All right. Now, let me go over a couple of things. First of all, what do you think is going to be on the test? What have we really worked on the most? Work. Which one did we work the most on? Tanks. So if I give y'all 5 questions on an in-class test that's not passable, what do you think 3 of them are going to be? Tanks. And the other 2? No, because half of y'all would put Dr. Gabati. What do you think the other 2 are going to be? Well, one of these, spring, and a rope or cable or chain. Now that's going to be your impassable test that none of y'all can pass. Okay. Now, what about the online test? Well, what did we cover in this 3 weeks of class, or whatever week we're in? I have no idea. All right. What have we covered? We've covered a review of Calc 1. We've covered basic integration, basic antiderivatives. We've covered, what else? Covered all that, area between curves. But what did we spend the most time on? Work. So if I give y'all 20 questions on a test, 80% of them will probably have to do with what? Work. I'm probably not going to give you 20 questions. I'll probably give you 10 or 15. Okay? But 80% of them is going to be on work. Now, my Calc 1 students will all tell you that whatever I tell you I'm going to give you, I'm going to give you. All right? But Wednesday, or what's today? Tuesday will be our in-class test and review. No, not in-class test. I can't do the in-class test a lot. We'll do the review and homework questions. Anything you want to go over, try to send them to me before class, okay? Because I don't want you surprising me with anything. Like, how much work does it take a rocket to move a planet? I don't want to deal with that, all right? But send me any questions you got so I can be going over them. I will have some questions that we will do in class that I like, hint, hint, and we'll go from there. Now, after class, Tuesday, what do I usually do? I usually show y'all the test, or I make the test. Did I make the test with y'all?
You did it on one.
Yeah,
I
you
did?
should us
You didn't do
like,
it every time.
Okay.
like these questions on them.
Well, the first test, be quiet, Mr. Brooks.
Well, plus it changes it every time, so it didn't really help.
Yeah, okay, well, I'll show you the test, the first test. I'll show it to you. Then you're going to go home. You're going to do the test once, twice, 3 times. I give you 3 forms. I have to do 3 forms because WebAssign what? Sucks. So I have to give you Form A, Form B, and Form C. You'll take the higher of the 3 grades. And then Thursday, you'll come in and take the in-class test that's impassable. Okay? Yes, sir. What's the question? Don't get up and leave yet. Am I not letting y'all leave early?
Whoa, whoa,
Why are you
whoa.
standing
Whoa,
up?
I was not standing up.
You were
need to
fixing
calm
to.
down. You need to calm down.
You were fixing to. What time is it? Y'all got 30 minutes. So I can take my dang time.
I know, but I wasn't.
What's your question? I'm sorry.
Will you take the test next Wednesday on that?
Huh?
Or
Thursday. I'm gonna have a test in here that's impassable.
It needs to be done by midnight Thursday, the test.
Okay, I usually give y'all a week.
A week?
Yeah.
A week to do it online?
Mm-hmm.
Yeah.
I give y'all a week to do it, and you got 3 times to pass it. And then y'all have to come in here and take the class, the one that y'all can't pass. And make sure you tell your next teacher that all of my in-class tests were what?